Let's do some integrals now with e to the x's. So the integral of e to the x dx. So if we're trying to find this antiderivative, what function gives us the derivative of e to the x? Well, that is going to be e to the x, right? We know the derivative of e to the x is e to the x, but remember, because this is an indefinite integral, there's no bounds here. We need to have our plus c. So e to the x plus c is the integral of e to the x. So let's see, how does this work out for us? So let's take the integral of e to the 2x minus 7. Now with this, you automatically will start to train yourself as that when you see integrals like this, you should always be thinking u substitution. So do u sub and you will be very happy. So what we're going to do with u substitution is I will let u be the integral, or u be the exponent. So I will say let u be equal to 2x minus 7, then du is equal to 2 dx. Remember, we pick our u, then we take the derivative. We're using differentials. I now get dx by itself, or I move the constants over, so I divide this 2 over here. So this becomes now 1/2, because of that, integral of e to the u du. Well, now I have the integral of e to the u du, which we know is just the same thing up here. So this becomes 1/2 e to the u plus c. But I don't want u's, I want x's in my final answer, so I substitute this back in. I have 1/2 e to the 2x minus 7 plus c. There we go, that is my integral. So up here, the same thing. Right, so what we should be looking for as another choice of u substitution is what is the exponent of e? It's a good choice. It's not always the choice we want, but it's a good starting point. So if I pick u to be negative x squared, so if I let u be equal to negative x squared, then du is going to be negative 2x dx. I have an x dx there, and I have the negative x squared. So what I have, my choices are perfect. I can replace all the instances of the variable x with something in terms of u. So it's a good choice for u substitution. So that means I'm going to divide over a negative 2, divide over a negative 2. So I have a negative 1 over 2 integral of 5 e to the u du. You can always pull out this constant of 5. So this is going to be negative 5/2 integral of e to the u du, but obviously integral of e to the u is just e to the u. So we have negative 5/2 e to the u plus c, but then I substitute back in. So I have negative 5/2 e to the negative x squared plus c. So there we go. Integral using u substitution. Negative 5 over 2 e to the negative x squared. Then over here, again, try the exponents, see what happens. So if I let u be equal to 1 over x, then my derivative is, I take the derivative of this. Now remember, 1 over x, it's the same thing as x to the negative first. I take the derivative by moving down the exponent and subtracting 1 from the power. So I have negative 1 x to the negative 2. Or in other words, this is negative 1 over x squared dx. And that's perfect. I wanted a negative 1 over x squared dx because I have a 1 over x squared dx. So that's good. I just have the negative that I need to move over here. So negative du is 1 over x squared dx. Now I substitute back in. So I have this is equal to a negative integral of e to the u du. So I have a negative e to the u plus c. Substituting back in, I have a negative e to the 1 over x plus c. So here we go. U substitution, very popular with your e's when it comes to integrating.